All right, let's take a look at today's lesson. We're going to be looking at dividing polynomials. Before we get into the examples of dividing polynomials, I do want to talk about these theorems. And I had a question earlier. Are we going to use these theorems in a proof? And I know that would be super exciting, but I'm sorry, I don't want to disappoint you, but we're not going to. It would be fun, but no, gosh, we're not going to do that. Of course, we still have we're still going to get to play with proofs on quizzes and tests and such, just not this kind of proof. It would be trig proofs. So let's talk about these theorems. The first theorem is the remainder theorem, and I really need to write a polynomial up here because it's so abstract. Students just kind of stare at me when I talk about it. It's like, what are you saying? So we're going to come up with an example, p of x. We have a polynomial p of x. Let's just say this is our p of x polynomial. Okay, there's p of x. So we have a polynomial and it's divided by x minus c. Okay, so, and in this case, if you're dividing by just with singular, this is to the first power, x minus c, you could use synthetic division, that's fine. If that's a 1, if we're just trying to find remainder, because that's what this is, a remainder theorem. If I were to divide it by x minus 1, if I were to divide it by that, basically what this is saying is the remainder is going to be p of 1. So if I were to divide that out using synthetic division or whichever, or long division, the remainder that I get is going to be the same thing as if I plugged a 1 in here. So I plug a 1 in here, I get 4, 5, 6, 7, 8, 9, 8? So I can actually plug a 1 in here, or this theorem tells me I could divide by this and I'm still going to get the remainder of 8. That's what the theorem means. That's all it means. Yes. Yes. C, just the number c. The negative is part of the formula. So, the number c. All right, synthetic substitution. So, likewise, if I want to use synthetic division, and I want that, basically putting this, using this 1, I use the 1 and I do my synthetic division for 0, 3, 2, negative 1, bring the 4 down and such, do all that. I should get 8 as my remainder. That's what all that means. Synthetic substitution is doing that, is finding what that would be. Factor theorem. C is a 0 of the polynomial if and only if x minus c is a factor. Well, that makes sense. We know 0. If I have a 0 of c, how do I make the factor? It's x minus. We talked about that yesterday, right? That makes sense. That's just what we do. That's just how that works. And those are just some theorems that I'm not going to test you over them. You don't need to memorize them. I just think it's important to talk about so you are aware that they exist. Okay? So now we're going to do a few examples. So if you would flip to the second page, let's do some examples of division. So the first one basically gives us a fraction. It says divide. So of course it's the numerator divided by the denominator. So let's do that. So 2x squared minus x plus 2 is my divisor, my dividend. Now let's talk about this for a second. I'm missing an x cubed. Now, do I have to put in plus 0x cubed? I mean, I don't have to, but it would be really convenient for me to do so. It's not a deal breaker like it is with synthetic division. If you don't put the 0 in synthetic division, you're going to get wrong answers. But here, it's not a deal breaker. I'm going to go ahead and put it in. I think it makes the work easier. So plus 0x cubed plus 6x squared minus 3x plus 1. Okay, so just a reminder, I know we covered this last year. We are going to use this first term of the divisor, and we're going to see how many times it goes into the first term of the dividend. Now, I really like multiplying better. So what I do, the thinking process that goes through my head is I think, okay, what would I have to multiply 2x squared by to get 8x to the fourth? I mean, that's what I'm thinking. What would I have to multiply 2x squared by to get 8x to the fourth? Well, if I have a 2 and I need an 8, I need a 4, right? I need to multiply by 4. Does it matter where I put it up here? No, I don't really care where you put it up there. So 4, let's see, and it would be 4x squared. Let's check that out. If I multiply 4x squared times 2x squared, yep, I get 8x to the 4th. Okay, so let's do that. Once I find that number, I've got to take it and multiply it by all of the terms of this divisor. So 4x squared times 2x squared is 8x to the 4th. 4x squared times negative x is negative 4x cubed. I want to pause here for a second. If I hadn't written this 0x cubed in here, and I would have had the 6x squared in front of it, when I go to subtract, I'd have been like, oh, that's weird. But we know that we can't subtract x squared and x cubed. That's not going to give us anything. So it's not a deal breaker. It just makes it a little strange. So I like that I put the x cubed in there. All right, so let's keep going. So 4x squared times 2 is 8x squared. Now, here's my recommendation to you. I make sign errors. I'm sure all of you in one time in your life has made a sign error. I am far less likely to make a sign error when I do this every single time. I put parentheses around it, I put a subtraction there. Every single time. I am far less likely to make a sign error when I'm subtracting here. But it's your choice. You do what you like. So let's subtract. This minus this goes away. 0 minus a minus 4 is a plus 4, x cubed. 6 minus 8 would be a negative 2x squared. And I'll bring my next term down. Okay, so let's go again. I have to think to myself, what would I multiply 2x squared by to get a 4x cubed? Well, 2x. So 2x times 2x squared is 4x cubed. 2x times a negative x is negative 2x squared. 2x times 2 is plus 4x. I put my parentheses in a subtraction. Okay, that term goes away, that term goes away. Negative 3 minus 4 is a negative 7x. Bring my next term down. And now I think, is it possible for 2x squared to go into 7x? And it's not. So that means that this little guy is the remainder. Now there is a way that you write the answer that would be the proper way to write the answer, which is how we are going to. Because this is in preparation for calculus. Why would we do this in calculus? If I was asked to integrate this fraction, this is how I would start. I would do long division. And then that means that I'm going to integrate this whole, those are whole numbers, and this is a fraction. So this is what I would integrate. 4x squared plus 2x plus a negative 7x plus 1 over 2x squared minus x plus 2. That is how I always want you to write your answers. Always. With the whole portion and the fraction portion, because that's what you would be using it for next year. Okay, so that is long division. Just a reminder, how are we doing on that? Okay? Okay. The second problem, we have a polynomial. And we're given a 0 of 3 plus I, and that's one of the zeros, and they want us to find all the zeros. Okay, so yes, you could use synthetic division. I don't really like synthetic division, and I'm not going to, because it's really actually pretty complex with imaginaries. If I try to use synthetic division with 3 plus I, I'm going to get a bunch of imaginary answers, and then I'm going to do 3 minus I to clean the imaginaries up. I just don't want to mess with that. So I'm going to do, you could do it if you wanted to. I'm okay with that. But I will show you what I would do. What I would do is I would take these two, this, you know, it has a little partner, right? 3 plus I isn't by itself. It'd be too lonely, right? 3 minus I is also with it. So I'm going to take the zeros, 3 plus I, and 3 minus I, and I'm going to use this formula, x squared minus sum x plus product. I'm going to create the quadratic that these two would be factors of. So I'm going to add them together, so plus, so that would give me a 6. So I have x squared minus 6x. Then I'm going to do, so that's the sum would be 6. Then I'm going to do the product. 3 plus I times 3 minus I. So 3 times 3 is 9. Outside, inside go away, minus I squared. I squared we talked about yesterday is a -1. So I have a -1. So this is going to give me 10. So this is my quadratic that would be created by these two roots. So what I'm going to do is I'm going to divide this quadratic out of this polynomial. What I have left over is going to be a quadratic, right? If I take a quadratic out of a fourth degree, I'm going to have a second degree. Then I'll find the roots of the quadratic. That's what I'm going to do with whatever technique I want, right? We could factor if it's possible, complete the square, quadratic formula. We got lots of things to do. So that's what I'm going to do. And let me get a little bit more room right here so we can do that. Let's just move some of this out of the way. All right. So we're going to take x squared minus 6x plus 10, and we're going to divide that out of x to the fourth minus 6x cubed plus 6x squared plus 24x minus 40. That's what we're going to do. Now, since this quadratic was created by factors of the polynomial, if I don't come out with a zero remainder, I've done something wrong. I should have a zero remainder. There should be no remainder when I finish my division. So let's start. So I have to think to myself, what would I multiply x squared by to get x to the fourth? Well, that would be, what, x squared. So x squared times x squared is x to the fourth. X squared times a -6x is -6x cubed. X squared times 10 is plus 10x squared. Okay, I'm going to subtract. So the first two terms go away. That's kind of nice. Then I have 6 minus 10 would be, what, a -4x squared. Okay, now I'm actually going to bring down the next two terms. I'm going to bring down the next two terms because I have 3 terms here, right? And I would really need 3 terms here. So let's bring those down, plus 24x minus 40. Okay, so let's divide again. So what would I multiply x squared by to get a -4x squared? What, -4? So -4 times x squared is -4x squared. -4 times -6 is a positive 24x. -4 times 10 is -40. Fantastic. We did not make a mistake. The remainder is 0. So what that means is that this quadratic is going to yield the other zeros for us. This x squared minus 4. X squared minus 4 equals 0. So I would factor, and I get x is plus or minus 2. If you want to live dangerously, you could move the 4 over and square root both sides, but one of the most common mistakes for students is to forget the plus minus. So, you know, if you want to live dangerously, go for it. Just move the 4 over, square root both sides, but you need to remember it's plus minus. So we find all the zeros. So we have a plus minus 2, and we have a 3 plus or minus I. Those are all of our zeros. Okay, we know because it's a fourth degree, and I have 4 zeros. Okay, we doing okay? Okay. All right, so the next one is kind of crazy. I'm just going to say it kind of drove the earlier class a little crazy. So let me talk about it a little bit more. So what we're going to do, we need to find k so that the remainder is 0. Now, we're going to use long division. There were some students that wanted to use synthetic division. Let me talk about synthetic division. Synthetic division only works properly if the coefficient of this is 1. So, you know, you could use it to practice, I suppose, but I'm definitely not going to give you one on a quiz or a test that's in this form so that you could use synthetic division. You need to know how to do it with long division. Okay, that's our process. We're working on long division. Okay. So here we go. We're going to divide. We want the remainder to be 0, and we're going to divide. So I'm going to take this kind of slow, so kind of go with me. So we're going to take x minus 2, and we're going to divide it into x cubed minus kx squared plus 2x minus 4. Okay. We're going to go slow. So x goes into x cubed, x squared times. So x squared times x is x cubed. X squared times negative 2 is negative 2x squared. Okay, normal so far. Now the weird part comes in where we have to keep the k. That's the weird part. But it's really, truly just long division the whole way. Okay, so just keep that in mind. It's just long division. We're going to have some weird stuff with it. So when x cubed minus x cubed is 0, minus kx squared minus a minus 2. So what that's going to give me is minus k plus 2, and that is going to be x squared. Okay. I'm going to bring down my next number, plus 2x. And I'm going to keep going. Okay, so I know this is going to be weird. I'm going to keep going. So what would I multiply x by to get this x squared? Well, minus k plus 2x, right? And I'm going to keep it in parentheses because it's just a little weird thing. Minus k plus 2x. Minus k plus 2x times x is minus k plus 2x squared. Minus k plus 2 times a minus 2 is minus 2 times minus k plus 2, let's get this in, x. So I'm going to pause there for just a minute. We're going to rest for a minute, okay? So let's make sure we understand what's going on. I multiplied this times x and got this. Okay, that should be okay, right? I multiplied this times negative 2 and got negative 2 times this. I haven't distributed or anything. You might want to distribute. I don't know, whatever you like. Okay. So now I'm supposed to subtract, right? I subtract. This part goes to 0. I think that's pretty clear. So here I'm going to write out the subtraction. I've got 2 minus a minus 2. So plus 2 times minus k plus 2, and all of that is x. So let's pause here for a second. So let's do that again. So I had 2 minus a minus 2, so 2 plus 2 times that mess, and that's x. I'm just subtracting the coefficients. And I know that looks like a big mess, but that's all I'm doing. Then I bring down, so this would be, I bring down the negative 4. Okay, so what do we do now? So we ask ourselves, what would we multiply this by to get, x? What would we multiply x by to get this? Well, that mess, right? And this top part doesn't really matter. I mean, you could put it up here. 2 plus 2 times minus k plus 2. We multiply that times that, and we get 2 plus 2 times minus k plus 2 x. That times that. Then I multiply this times the negative 2. Negative 2 times that mess. 2 plus 2 times negative k plus 2. Minus. Okay, here's where we get to break free. Now what we want to do is we want minus 4 minus this mess to be 0. That's what we want, right? We want minus 4 minus all that to be 0. So I'm going to write that out. I want minus 4 minus all this mess minus minus 2, so that's plus 2, times 2 plus 2 times negative k plus 2. I want all that to be 0. That's what I want. Okay. So here we go. So let's see this little guy. Okay, so we have minus 4 plus 2 times 2. Let's distribute this out. So we get, what, minus 2k plus 4 equals 0. We get minus 4 plus 2 times, let's just go ahead and distribute it out. Come on, little guy. There we go. Okay, so 2 times 2 is 4. 2 times negative 2 is negative 4k. 2 times 4 is 8 equals 0. That goes away. I have 8 equals 4k, or k equals 2. If you wanted to check it, you certainly could. You could put a 2 right here and divide it out and make sure you got 0, and I have checked it and it does work. That's highly abstract. I know that's very complex, and I have a couple of examples like that on the daily work for you to practice. Okay? Questions for me? All right.